Thanks everyone for giving me this opportunity. My name is Subbu Sethuvenkatraman. I am from a research agency in Australia. I'm coming to you from down under. I'm a group leader in the energy business unit of CSIRO. In the next 20 or 25 minutes, I plan to take you through some of our experience in terms of managing operating a data platform for delivering intelligent building services. So I'll broadly talk about cover three topics here. I'll again refresh, memory in terms of the barriers to intelligent building operations and take you through some of the challenges, and then introduce our data platform, data clearinghouse, and talk through some of its features. Then I will spend a bit of a time sharing our experience in terms of delivering building services through this platform and some of the learnings and where the industry is at right now. So in terms of getting a building intelligent buildings or smart buildings operating in a scalable way, we have a few barriers again to refresh people's memory. The first one is data access barriers. Once you have got access to data, you can do wonders, but we all know the data in buildings is siloed, and you have got various ways to collect the data. You could be collecting data from building management systems. People will still be accessing drawings. Still, we need to do site visits and also talk to building managers to get information about the data. The second challenge, again, primarily with respect to accessing data from building management systems to a large extent, is the data usability barrier. The data that's available is in a non-standardized format, and not everybody can actually use the same type of information to do the type of services they want to deliver. What I have shown here is a typical example of a few building management system points from few of the buildings that CSIRO operates from 3 different sites, and you can see a typical point name how that is actually coded by the contractors while they commission the building management system. And again, obviously you can't use the same code or information to deliver these services across these multiple buildings. The third one is perhaps the data silos in terms of, the data is currently available and again, managed by service providers, but they are all siloed. There are vendor lock-in challenges and also building service providers. Even though the data that may be collected is of same type, or the data needs may be of same for same applications, people will still be installing their own sensors, and there is an additional cost of having a connection, and then data hosting cost, and also in order to deliver the applications or services. So this vendor lock-in challenge is a big barrier that industry has been trying to overcome for ages. So how does data clearinghouse actually support or address these challenges? So we have built this platform, data clearinghouse, and operating it for over a few years right now as a one-stop shop for managing all operational data in a building by integrating diverse data streams. It's a data governance and enforcement platform, so it helps manage access to data and facilitate data discoverability. So it primarily places the data ownership in the hands of the data owner, who is most likely the building owner. And also one of our ambitions is actually enabling a marketplace for data-driven services for delivering intelligent building operations. It could range from energy efficiency to operational cost savings, and also convert this into a mobile phone-like app ecosystem where these analytics could be self-deployed. One of the ways we achieve this is using semantic models, and we use brick schema. Again, I'm not going to go into details of the semantic models, but creating semantic models and the challenges associated with managing semantic models is something which I'll touch upon. And the aim here is, once you have got all the data available through standardized models, that becomes the single source of truth, and you can easily manage that and use that for managing all the building operations going forward. Again, just to be clear, we often get asked the questions around, what is data clearing house? Is it something like Amazon cloud service? It's not. So we kind of created this FAQ. It's not a cloud BMS. We basically facilitate, help manage all the data from a building and then facilitate access to, even third-party data for the, for all the building industry stakeholders. It's an application enablement and hosting platform. Again, we are not, the aim is not competing with existing application providers or service providers. We again facilitate access to data for application providers, by avoiding spending time on setting up infrastructure and also ability to understand, what the building has got and all that, initial legwork. Again, as I mentioned, we use semantic models to organize and find data. It's not an SQL database or so. Just to give you again quick summary of what Data Clearinghouse does, we provide, we have built connectors and we continue expanding building connectors that actually help connect various types of building building sources, data sources into the platform using, again, standardized methods. And once the data is in the platform, again, people who work in the domain obviously know about the challenges of having good quality data. And we do care about, again, making sure the data is cleaned and the data quality is maintained. That's one of the key things the platform aims to achieve. And also helping people to access data through semantic models and providing tools like APIs for, again, application providers and service providers to get access to data. We have built various applications or demonstrated deployability of various applications through the Data Clearinghouse. You can see in few of these examples listed here. Again, the focus of this talk is more around the part of getting buildings connected to a platform and the challenges associated with that. I'm not going to spend lots of time talking about the intelligent building services that can be deployed or the benefits we have seen with operation of these services in the platform. The platform is an active platform. We have got a growing user base. We have got over 200 buildings. We have been operating it for the last 4 or 5 years now. It has got a range of buildings, ranging from office buildings, mixed-use buildings, schools, hospitals, various types. We also use it as a research infrastructure for various energy productivity and buildings to grid integration research as well. So thinking about our experiences in terms of, how do we, how did we go about connecting, let's say, 200 buildings? If I have to summarize the process, it's a 3-step process. The first part, what we call as onboarding, consists of 2 things. One is, connecting the building data sources onto the platform and ingesting the time series data. Again, we use industry standard protocols like MQTT, and also we facilitate access through APIs and all of that. Probably the more important one in terms of managing or building data through semantic models, standardized building models, is ability to collect all various sources of data and metadata in a building to create building models. And again, this is not a trivial task, and people know this is where lots of effort goes in. And we have been trying to see how do we work with existing industry partners to address some of these challenges. And once you have got access to data, time series data, and once you have got a building model, then the application providers or the service providers can access the data using a standardized query engine like Sparkle, and then they can deploy their applications either through the platform, or they can also do it off the platform. And deploying analytics is the 3rd step. So when you think about this, there are lots of industry stakeholders involved, and new skill sets are required, and that's what I'm going to share some of our learnings here. So when we talk about delivering these intelligent building services or smart building services, there are various stakeholders in the mix, and I'll just talk about a few primary stakeholders here. For example, system integrators who traditionally do the job of onboarding a building, connecting a building management system or so, they are now tasked with additional work. They probably or most likely are the people who would actually be tasked or working on the playing the role of creating semantic models. And then we have got analytics provider, or the intelligent building services provider. For them, again, currently they used to go to a building, again, hardwire all their applications into the platform, which again limits its scalability or deployability. But currently, they need to be knowing how to access data and data models in a building so that they can actually deploy their applications in a scalable way. And that again, that's something which the existing analytics providers either are equipped or they need to learn new skill sets to actually do that in a cost-effective way. Um, in terms of managing building data, obviously there are data platforms or cloud services that can do that. But managing semantic models is a new skill. And again, the semantic models, as I mentioned, if we are expecting it to be a single source of truth for a building going forward, there has to be ways to making sure the platform, the models can be managed over the platform's lifetime, and there should be tools to support that. Building manager, who probably is the one who kind of benefits out of this and then delivers building services, cost-effective building services to end users, they need to be seeking approvals and taking permissions to get this all going. So talking about some of the challenges, as I mentioned, the system integrators need tools for creating building models, because most likely not, we don't want them to be learning brick, or we don't want them to be learning semantic ontologies, and that's a barrier we would like to address. And as I mentioned, the some analytics developers, they need to have the skill set to deploy scalable analytics. And in order to do that, they need to know how to query building models and then find the right data that their application needs, so that they can actually deploy these analytics. And again, currently we have seen the traditional analytics providers, we either have researchers or energy modelers who probably do not know these new skill sets, and how do we equip them with skill sets, or do they need to be even knowing things like tools like Sparkle before they go ahead and deploy their analytics. Platform manager, again, I mentioned about the readiness to support building model over its lifetime. And again, the questions of how good a model is and semantic sufficiency. And again, do we have methods to verify the accuracy of a model? They are some of the challenges, again, we need to support the platform managers or platform owners with. Building managers, as I said, they need to go through, even though they see a use case or a business case for delivering a smart building service, they need to go through various approvals. This actually includes taking approval from the the IT team, because so far in a typical smart building service where you are not cloud connected or you do everything in-house, there is no need for a specific IT approvals. But with things everything being cloud connected, you need to not only take approval from the building owners in terms of delivering a business case, but also work with stakeholders like the IT team to take approvals. So just dwelling a bit more on the model construction aspect, the main questions when we started building, creating semantic models, working with industry partners. One of the things we have done all along our journey related to data clearinghouse is we always work with industry partners. We have created a panel of system integrators who signed up to support and work with the DCH, and we have been interacting with them almost on a regular basis to see how we can equip them with the tools and methods to come through this in a come through this learning curve in a scalable way. When we started creating building models early on, there was this question obviously about how much effort someone spends to create a building model. Do you go ahead and then say, look, I want an all-encompassing model that has got all nitty-gritty details of a building, or should I create a building model only for the application it needs? Again, it's not an easy question, and again, we have to look at things like the effort required in data preparation versus how useful will that be? Because oftentimes we have seen some of the early buildings we have onboarded onto the platform. We don't use probably 90-95% of those points with the analytics that we want to deploy with those buildings, and also the associated ongoing maintenance of the models, because the semantic models, for example, Brick has been undergoing upgrades, again making sure the models are up to date and the building undergoes changes, and more importantly the accuracy. Again, if all of these changes are happening, making sure the model is up to date is a big challenge. So the one of the questions the industry obviously wants to know is how should how detailed the model should be. And again, purely looking at it from a system integrator perspective, they also intimately link this to the costing, because they need to be providing a quote and they need to be delivering the services without really knowing what they are building, or how much details should go into a model. They can't easily quote, and so they look at it from a practical point of view. They want to understand how do you really specify the need for models such a way they can actually deliver quotes that are reasonably accurate, so that they don't have to come and revise the quotes later. So in order to address this challenge, we have been looking at a few things. One is obviously developing a AI and ML-based model construction tooling, which again, I'm not going to touch upon in this talk. We have also recently seen use of tools like large language models has been helpful in creating a building model to an extent. In terms of, let's say, if you take a drawing or the metadata information available from building, how can you use ML-based tools to create processes that system integrators can use. This is obviously a work in progress. The other thing we have seen in terms of, again, helping system integrators manage this process of model creation a lot more effectively is standardizing the model construction workflow as much as possible. For example, one of the things we have done is creating a process where we can specify the model construction as level 1, level 2, level 3, or level 4, depending upon the complexity or the information that needs to go into a model. For example, we call level 1 as models that only needs to, where the model needs to be built only based on the application or the analytics it would actually be using. For this, obviously, the client needs to clearly specify these are the applications or analytics they would be interested in benefiting out of this model. And then it's easy to identify those points and then create a model that's only based on that. The second level of model creation to a large extent boils down to creating models that belong to a single discipline. For example, if you're looking at only the mechanical services or HVAC system, you only create a model for that. You don't do more than that. The level 3 building models are probably looking at something, not only a single discipline, but looking at interdiscipline. For example, if you are looking at connecting mechanical services with electrical services, so you can actually have got energy metering data as well. And level 4 is something where you try to create a model encompassing all the points, which almost feels like a digital twin, where you have got all the information about the buildings, which can be useful for starting from in terms of optimization to research services to all of that. So classifying the model construction activity into these, into different compartments or levels has helped us to interact with the system integrator partners much more effectively, because they can actually at least see when, before they quote a job or before they get into a job, what kind of complexity they are looking at. And again, purely from their point of view, if you take an example of level 2 and level 3 model, they know how do they access level 2 information if it is related to only one service. But if they need to access additional information, for example, if they need to access all the, not many buildings have energy management systems, but if they have to go, get access to the energy metering points and energy management system, they know they need to talk to different set of people, and that's an additional effort. So they can easily account for the additional cost that is involved in quoting for that job. So we have been trialing this process for the last 1 year or so, and we have seen positive response from the industry stakeholders. And again, if someone is interested, I can share the details of detailed specification. What I have shown here is a screenshot of what level of details goes into these different level of coating for a building model construction. And as I mentioned, the existing industry partners have shown positive response towards embracing a method like this, which kind of helps streamline the process. The other challenge related to onboarding, which again, in the interest of time, I would briefly touch upon, is the cybersecurity and the data sharing challenges. As I mentioned before, if you are not cloud hosted, or if every data is managed on the within the building, there are previously there used to be system integrators who probably come and connect a building, and every data remains within the building, and it's probably there is not much role for a the IT team from the building or from the services to get involved. But when we talk about connecting data to a cloud platform, the role of the IT becomes very important, and oftentimes we have seen that is one of the big challenges. That's mainly because the IT processes or people who are actually tasked with approving connecting a building to a platform or sharing data outside the building often do not have their briefing clearly provided. They don't know what is their role. They don't know why they are approving something, and they don't know what are the future implications. Neither the building manager has briefed them, or the building owner hasn't told them this is one of your role, and you need to be providing support with connecting a building OT and IT systems to a cloud. They don't have it in their briefing, and that lack of clarity creates lots of challenges. And again, we are working with partners to overcome that. The second aspect where we have seen, again, the big benefit can happen in terms of providing approvals is having a data champion inside the organization. Again, lots of large organizations or even medium organizations nowadays are thinking about having a data owner. Again, we can call them by different roles, a data steward or a data custodian. And having a data champion inside the organization helps interact with these various stakeholders by reducing the risks in terms of data sharing, and also providing clear documentation in terms of sharing data with outside the organization. And this could still be a challenge for small and medium buildings where they cannot probably afford to have an independent data steward or a data custodian. But we have seen having a data champion inside the organization helps us smoothline this process and overcome the onboarding challenge. So in summary, data clearinghouse is an enabling infrastructure for unlocking value out of building data by overcoming data access barriers. Yes, the industry is obviously under transition. There are new skills required, new roles required, and there are new expectations out of people. And what you have seen is taking all the industry stakeholders along the journey is really critical for scalability. And we do that by developing industry-ready tools and processes. And what you have seen is the industry is responding positively to these changes. Thank you.
Hi, thank you for your presentation. Very interesting. Maybe I didn't get it, but so the data cleaning house, is it like an open source software solution? Is it provided as a SaaS? Like, what's the model behind it?
Yeah, it is provided as a SaaS. People can actually register to access the platform, to onboard their buildings onto the platform, and also we can work with the application providers to host their applications through the platform.
Thank you.
Can you pass the mic back over there?
Hi, thank you. Great presentation. I think one thing I was thinking was with Brick, although there is a schema, there are still modeling choices. For example, one person can model zoner temperature sensor, while another one can use air temperature sensor and then tie it to a zone. And that kind of cause problems when you're writing queries because you need to know these modeling changes. So how do you handle these kinds of situations?
Um, that's really a very important question, and we create what we call as modeling norms. And there is a detailed model creation documentation that tries to specify how do we constrain how brick should be deployed. And obviously there could be changes between different service providers, but at least for data clearinghouse, we try to constrain how the model construction activity should happen so that different model creators are working on creating a platform. They need access to a documentation that articulates how to use brick schema to implement it in the data clearinghouse. So we call it DCH norms, and the norms document helps building model creators to go ahead with creating a model that's almost similar. Yes, that's an important question, and the industry is already addressing that by constraining the way the brick should be implemented.
I see. Thank you.
Here, I got this one over here.
All right, thank you very much. This is the topic I have been waiting to hear about for a long time, so that's very exciting. I think like this semantic model is important, and you are speaking to the kind of an important aspect of it, right? But my question is, who do you think should be creating this semantic model? Is there any way to automate this process? Because really the semantic model is bridging data to useful analytics, right? And this is important, kind of a bridge point. But it is also most time-consuming part of this task. So if we can develop something, some automated tool to streamline this process and reduce the engineering effort to develop this model, that will be a big impact to the industry. So are you aware of any automated algorithm that can do this for us? And also, who do you think should be, which stakeholders do you think should be kind of operating this or implementing this algorithm? You mentioned multiple stakeholders like system operators, building managers, and a few others. So who should be the one that manages all these processes? Thank you.
Yeah, again, very important question. We believe system integrators are better equipped to deal with the challenge of creating a semantic model, primarily because they do have access to building and the building managers or the facility managers, and also have access to the metadata from buildings. However, what we have seen is the traditional system integrators are not equipped to deal with semantic models because they are not familiar with, probably many of them use tagging. For example, they use schema like haystack reasonably well, and that's mainly because lots of building management gateways or hardware already have got tools for creating those tagging in buildings. And in a similar way, we believe if you are able to create tooling for creating semantic models like brick through gateways or other services, that's going to help system integrators. And that's what the industry, and I know lots of researchers have been also working on, including ourselves. We have been one thing which I did not touch upon in this talk is using AI and ML to see how can you use, for example, the building point information to help create brick classes or brick relationships. So certainly tooling is going to help in a very big way, but that's obviously evolving right now, and I'm not sure if there are very mature processes that people can use straight away to to 100% accuracy. So my answer would be yes, tooling would help in creating semantic models, but it will still be an assisted process. I think at least I don't see how we could actually have tooling that will create help in creating 100% semantically accurate information of a building. Perhaps there is some more way to go, but certainly we can use assisted tools that can help simplify this process.
Gregor has raised his hand online. I think he wants to ask a question. Ask a question?
Yes, Gregor
Gregor,
has, sorry, go ahead, Gregor.
Gregor? Oh, you're muted, I think.
There is
cannot
a
speak.
message in the chat. I can read it. Gregor is asking, how do we respond to the workforce challenges in university education?
No, he's not a co-host. There we go.
Gregor, I think from a university education perspective, or at least from an application users or analytics developers, we have certainly seen the researchers or people we engage in the industry having a good mix of experience with respect to their domain knowledge and the background they come with, and also having the relevant IT skills. That has been a challenge, and again, I know there are lots of universities that are adapting to this by having curriculum that actually help even mechanical engineers equipped with to a large extent with at least basic level of programming skills, and that is certainly something that's going to help. And from a point of view of semantic model creation and system integrators, I believe vocational training or probably industry ready training courses that helps them understand this tooling is probably a way to go.
Hey, yeah, I think it calls for an interesting blend of educational content, engineering and IT, right? To really respond to that need that you addressed. So thank you.
Great, thank you very much. I think we should move on. Thank you.
Thank you.